In this PPT, we will be basically going to see what are the different types of connecting or networking devices are there. We will see one by one what are different types of connecting devices are there. These connecting devices are the one that will be basically defined with respect to different layers of the internet layers or the OSI model that we have gone through. Okay, so in this section, we will be dividing the connecting devices into 5 different categories based on the layer in which they operate in a network. So inside a network, what different layers are there? With respect to that particular layer, there are different interconnecting devices. So with respect to that layer, we will be looking like there can be 5 different types of networking devices can be there, connecting devices can be there. So the 5 categories are basically defined. So these 5 categories will be basically defined with respect to these criteria. So the first is like those which operate below the physical layer, such as a passive hub. So the first category will be like the passive hub. This will be operating below the physical layer. So physical layer is the first layer if we talk about into the internet layer basically. So it will be basically dealing with the passive hubs. The second criteria is those which operate at physical layer. Okay, so this the first one is below physical layer. The second is that operate at physical layer. So at physical layer, there will be the connecting devices that will be called like a repeater, or another type of devices will be an active hub. So either it can be a repeater or it can be an active hub. So these are the devices that basically operate at the physical layer. So it will be the connecting devices that will be operating at physical layer. So next criteria is those which operate at physical and data link layer. So if a device is there that is basically going to operate at physical and data link layer at both the cases, both the layers, then it will be called like a bridge. It could be a bridge, or it is also called like a two-layer switch. It will be called a two-layer switch. Okay. Next criteria is those which operate at physical, data link, and network. So if it is going to use 3 different means the connecting devices that will be utilizing these 3 layers to operate, or it will be operating in these 3 layers, that will be the routers. So a router will be the one that will be utilizing the 3 layers. It will be operating in that 3 layers. So it will be a router, or it is also called like a 3-layer switch. Next criteria is those which can operate at all 5 layers. These are basically called like a gateway. So these are the different connecting devices that are basically being defined at different layers. So we will see one by one what these connecting devices are there. So here pictorial representation of these different connecting devices at different layers are given. So the passive hubs are just below the physical layer. So it is just below the physical layer. These are the passive hubs. Then at physical layer, there will be repeaters. Repeaters or hub here. These hubs are like active hubs. And then the bridge or two-layer switch. This will be operating at both physical layer as well as the data link layer. Next is router or a 3-layer switch. It will be operating at network, data link, and physical layer. So it will be considering, or it will be utilizing the physical, then data link, and the network layer. Similarly, the gateway, it will be utilizing all the 5 layers basically. So this is the basic idea, like how we can represent these connecting devices with respect to different layers of the internet. So we will be starting with the first, like what is a passive hub. So here a passive hub is just a connector. So it connects the wire coming from different branches. So it is the passive hubs will be nothing but a connection, a connecting device. So it will be just providing a connection between two uh, system or two connectors basically. Two stations are there, they are connected with wires. So this passive hubs will be just connecting two connectors of coming from two different stations. In a star topology Ethernet LAN, a passive hub is just a point where the signal coming from different stations collide. So in star topology, it is saying like star topology means there will be a hub and different devices will be connected. So it will be likewise. So if this is the case, so in that case here, so this is the hub. So it is based just providing the passive hub is just a point where signals coming from different stations will collide. So if signals coming from this station, and likewise all these station, they will be coming at this location. It will be coming and colliding. This is the uh, basic passive hub. So it will be like a colliding point or collision point will be considered as a collision point for the data coming from different stations. This type of a hub is part of the media. Its location in the internet model is below the physical layer. So you've just seen that. These hubs relay signals onto the network without cleaning. So it is not providing any cleaning facility or boosting facility. So it will be the passive hubs will not be doing anything. It will be just providing a connection. These hubs cannot be used to extend the distance between nodes. The meaning of this, like it cannot extend the distance between the nodes in the sense like if a node is here and another one is here, if uh, two nodes are there, so if we are using a hub suppose or a passive hub between two nodes, node 1 and node 2. Okay, so here if the nodes are distant apart, then these passive hubs will not be working as a connecting device here. So if nodes are arranged into a long distance, they need basically like the repeaters or the signals that coming from node n1. They should be going, and after some time, after some distance, they will be degraded. So there should be a strengthening of the signal should be done. So that is not provided by passive hubs. So that's why the passive hubs cannot be used for extending the distance between the nodes. It is used only for limited distance between the nodes. It is not like not used to extend the distance basically. So next comes the repeater that will be basically worked at physical layer. So here a repeater is a device that operates only in physical layer. It will be operating only at physical layer. So here the signals that carry information within a network can travel a fixed distance before attenuation endangers the integrity of the data. So in the sense, so the passive hubs were basically to provide a connection between the different stations. But if you want to extend the distance, then there should be some other devices instead of the passive hubs. So that the limitation of passive hub is basically removed by the repeaters. So repeaters is like it will be here it is saying like if we are having a data needs to travel a certain distance, then there is a chance of attenuation. So if attenuation means the data integrity will be lost. Okay, so that there is a repeater. So a repeater receives a signal. So what basically a repeater does is a repeater receives the signal, and before it becomes too weak or corrupted, it regenerates the original bit pattern. So repeater will be the one like if it is a repeater, so it will be taking a data. If suppose the data is going to be lost, then its strength is weakening, then the repeaters will be used to increase its strength of the data. so that it will regain its original bit pattern. So this is the role of a repeater. So the repeater then sends the refreshed signal. So after refreshing the signal, it will be sending the signal. A repeater can extend the physical length of the LAN. So what is the disadvantage of the passive hubs? It is basically removed by the repeaters. So it is shown in the figure here. So this is the repeater shown here. So a repeater is not a device that can connect two LANs of different protocol. So there are some limitations to uh, the repeaters also. So it cannot extend uh, the connection between two different LANs having two different protocols. It cannot uh, connect basically two different LANs of different protocols. Okay. Okay. So to extend this length, cable divides into segments and repeaters are installed between segments. So it is like if it is going to extend the length of the LANs. So repeaters can be used to extend the length. So if it is going to be used to extend the length, then each length of this cable on either side of the LAN will be considered as a segment. So it will be a segment. So one portion will be segment. So the repeaters will be supporting uh, the connection between two different segments. So one segment of LAN 1. So this is basically the LAN 1 and this is the LAN 2. So LAN 2 in the sense different data, different systems are connected in between. So that will be a part of LAN. So there is a LAN network 1 and LAN network 2, but they are operating at the same protocol. Then repeaters will be helpful. So note that the whole network is still considered one LAN, but the portion of network separated by repeater is called the segment. So segments, the separated portions, it will be like six separate segments, and this is separate segment as a whole that can be part of a single LAN. So here the repeaters act as a two-port node. So two-port node means it is having a two-port, port one here, another port here. Okay, so two ports are there, but operates only in physical layer. So it will be only operating in physical layer. When it receives a frame from any of the port, it regenerates and forward it to the other port. Regenerates and forward. So this is the role of a repeater. So a repeater connects segments of a LAN. This is the point we can think of. And a repeater forwards every frame and has no filtering capability. So this is the disadvantage if we talk about, or the limitation of the repeater. So it is having no filtering capabilities. So filtering, what is filtering capabilities? We will just see. So if it is having no filtering capabilities, so there should be a system or connecting devices that should be having the filtering capabilities also. Okay. A repeater is a generator, not an amplifier. So important point. So it will be just generating the signal, but it will not be amplifying it. Okay. So it's like if whatever the strength of the signal is there, if it is weakens or it is deteriorated, then it will be just increasing its strength, but it will not be like amplifying at whatever level it is there. It will not amplifying to it's higher than the original level. It will be regaining the original level. That is the basic idea. So it is the regenerator, not an amplifier. So here the function of a repeater is given. So it is saying like if this transmission of the data is from right to left side. So from right to left side, the data is going. So suppose at the right side, there is a corrupted signal. So its strength have weakens or it is deteriorated, then what it is going to happen is once it will pass through a repeater, its original strength will be regained. So this was the level, original level, so it is regained. So it is like a regenerated signal. Similarly, if it is left to right signal transmission is taking place, so if it is this side, a corrupted signal is there. So if corrupted signal is losing its strength, then after repeater, it will be regaining the same levels. So this is like regenerated signal. So this is the basic idea of the repeaters basically. Next, we will see the active hub. So active hub is also part of the physical layer. So it is working at the physical layer. So basically we can say like the hubs can be of two types, active and passive. So passive hubs will be working below the physical layer, but active hubs will be working at the physical layer. So here an active hub is actually a multi-port repeater. It is a form of repeater itself. So repeaters were the one that is having only two ports. So port 1 and port 2. So repeaters will be having only two port node. But active hubs are having the properties of repeater itself, but it is multi-port repeater. So it will be having more than one port. Sorry, more than two ports. So two ports were there into the repeaters. So in active hubs, it will be having more than two ports. So that's why it is multi-port. It is normally used to create connections between stations in a physical star topology. So in physical star topology, to make the connections, the active hubs are basically used. So this is the basic hierarchy of the active hubs. So there will be one hub, then this hub will be connected with some other hub, okay, and by the lower hub there will be the stations that will be connecting, okay. So these are the stations, different stations are there. So hubs can also be used to create multiple levels of hierarchy, okay. So that hierarchy is shown here into the figure. Hubs cannot filter data. So here also, similar to the repeater, hubs cannot filter the data. So data packets are sent to all connected devices. So if some data is coming, suppose D is the data coming from this hub to this one. So this hub will be distributing the same data to each of the station. So it is not going to have any filter. Okay, so this is the basic idea of active hub. They do not have the intelligence to find out best path for data packets. So they don't have the intelligence to find out the best path to transfer the data. So these are the active hubs basically. So next comes a bridge. So here a bridge operates in both physical and data link layer. So it will be operating in both physical and data link layer. These are the bridges. As a physical layer device, it regenerates the signal it receives. So because repeaters and active hubs operating at physical layer. So at physical layer, they were able to basically regenerate the signal. So as the bridges are going to work both at physical layer and data link layer, it will be having the property of regeneration at the physical layer, and at the data link layer, the bridge can check the physical, that is the MAC address. So physical address, that is MAC address basically, the source and destination. MAC address in the sense MAC address of source and destination contained in the frame. So at data link layer, the bridges will be able to check the MAC address of the source and destination that is available into the frames. Okay, so because we are talking about the data link layer, so at data link layer, whatever the data is there, that is considered as a frame. Next is a bridge has filtering capability. So what is the meaning of filtering capabilities? Its meaning is like it can check the destination address of a frame and decides if the frame should be forwarded or dropped. So the bridge have the filtering capabilities. So it will be providing the filtering capabilities based on whether uh, the packet should be dropped or forwarded. So based on the addresses, destination addresses, it will be able to find out whether the frame should be forwarded or dropped. So it is having a filtering capabilities. If the frame is to be forwarded, the decision must specify the port. So once the frame is to be forwarded, so decision must be specified to the port, in the sense from which port of the bridge the data or the frame should be forwarded. So it will be specifying like the port. How it will be specifying? It will be specifying with the help of a bridge table basically. So this bridge is having a table. So a bridge has a table that maps addresses to the port. Like if a particular physical address is there, physical address of a station, then this address should be if a particular address is there, if a particular station is there, so for that particular address, for that particular device or station, from which port the output data should be sent, so that it should be reaching to that particular station or that particular physical address. So that is basically stored into the table, bridge table basically. A bridge with a few ports can connect a few LAN together. So the basic bridge is like it is having few ports, so it can connect few LANs together. Another is like a two-layer switch. So a two-layer switch. So bridge is also called a two-layer switch, but this two-layer switch is a bridge, but it is having somewhat higher capabilities than a normal bridge. So a bridge with many ports and a design that allows faster and better performance and can be more sophisticated, they are called a two-layer switch. Okay, so two-layer switch in the sense, if uh, it's like an upgraded version of the bridge basically. So two-layer switch will be a type of bridge itself, but it will be having like many ports. So if bridge is having fewer ports, so it can connect only few LANs together. But if it is having higher ports, it can connect many LANs together. So it is called like two-layer switch. It can have a buffer to hold the frames for processing. So these bridges have buffer to hold some frames for processing, and it can have a switching factor that forwards the frame faster. So this is basically, these are the points basically for like two-layer switch. What two-layer switch capabilities are there? So that is having higher capabilities than the bridges basically. A bridge has a table used in filtering decisions. So the table is used. So how it is used? There is a bridge connection connecting two LANs. It is given. So this is LAN. This is like set of devices connected into LAN 2, and this is devices set of devices connected into LAN 1. Okay. So there is a bridge with two port. So port 1 and port 2. So if data needs to be sent from LAN 1 to LAN 2, so the bridge will be facilitating that data transfer. So suppose the case 1 is there. So into case 1, the device, suppose this is the device, or suppose this is the device that is going to send the data. Suppose this is sending the data to this device itself. Okay, so there is some data that needs to be sent from station 1. This is station 2, station 3, station 4, likewise you can say. So suppose station 1 to station 2 data needs to be sent. So it will be sending, S1 will be sending the data to the bridge. Now data in the sense frame will be coming to the bridge because it is data link layer connecting devices there. So the frame will be coming to bridge, and this bridge will be forwarding or dropping the frame. This is the basic rule based on the table, bridge table. So this is the bridge table. So into the bridge table, it is given like if the, the data needs to be sent at S2, the station 2, its address is 42. So 42 is here, it is given. So it is mentioned port 1. Its meaning is the bridge should be sending the data from port 1 so that it will be reaching to this S2 device. But station 1 is sending the data from station 1, the device, the data is coming to the port 1 itself, and 1 needs to send to here because it is given into the bridge table. So it's in this case, here the frame will be dropped basically because the data is coming from this port itself, and from this port only the data needs to be sent. So from the same port it can't send it, so it will be dropping it. So this is how the dropping is done. Next we will take like case 2. So case 2 is suppose S3 wants to send the data. S3 want to send the data to S2. So if suppose S3 to S2 needs to be sent. Then S3 will be sending the data to the bridge by using port 2. Once the data that is in the form of frame is received at the bridge by the port 2, then it will be looking. So because in that frame there will be the destination address. So the destination address is S2, means this is the destination address of this station. Then it will be looking at this bridge table. So into bridge table, what is the address? This one was the address. So this address is telling like the data needs to be sent by the port 1. So here the port 1 is free now. So now the bridge will be forwarding the packet or the frame coming from S3 to this port 2 to device S2. So here the frame will be forwarded. So this is the basic working of a bridge that is having only two port. It is only two port. It is having only two port. So if the bridge is having higher port, it can have better capabilities also. Okay. So a bridge does not change the physical address in a frame. So physical in the sense MAC address. So this is the MAC address basically given. So MAC address, the bridge will not be changing the physical or MAC address while sending the frames from one port to another port. Yeah, the next comes switches. So switches is like is a multi-port bridge. So here this switches are the multi-port bridge. So bridge we have just seen. So this bridge is only having two ports. So this is basic bridge is only having two ports. So if a multi-port bridge is there, that will be considered as a switch. So a switch is a multi-port bridge with a buffer and a design that can boost efficiency. A large number of ports imply less traffic and performance. Because large number of multi-port is there, so it is having like less traffic, it will be having like efficiency will be increased or delay will be increased, and that will be having higher performance. So this is the switches. A switch is a data link layer device. It is a data link layer device. The switch can perform error checking before forwarding data. So the switch is having the capabilities of error checking before forwarding the data, which makes it very efficient as it does not forward packets that have errors and forward good packets selectively to the correct port only. So this is the basic idea about the switch. Okay. So in other words, the switch divides the collision domain of host, but broadcast domain remains the same. So in the sense like the same thing it is going to say like it will be basically dividing the collision domain of the host. So like in what domains are the addresses there is a collision taking place, it separates that. It will be broadcasting domain and the collision domain, it will be separating. So it will be separating so that means it is going to basically filter the paths or the domains through that the data needs to be sent. So if it is collision domain or the broadcast domain, if it is broad data needs to be sent, it will be sending by the through using the broadcast domain so that the data should not be collided or there should be no loss of the packets or the frames basically. So there are different types of the switches. So based on the different applications, there are different types of switches. You can just go through it one by one. So one unmanaged switches. So these switches have a single plug and play design and do not offer advanced configuration options. They are suitable for small networks or for use of an expansion to a large network. So for expansion or for small networks, unmanaged switches are used. Another one is managed switches, offers advanced configurations, options such as VLANs, virtual LANs, quality of service, link aggregation. So there are different facilities provided by managed switches. They are suitable for large and complex networks basically and allow a centralized management. So these are the managed switch. Smart switches, these switches have features similar to the managed switches, but are typically easier to set up and manage. This were the complex one, more complex. This were the easier. They are suitable for a small to medium sized networks. So layer 2 switches, yeah. So different types of switches are there. You can just go one by one. So here the layer 2 switches. These switches operate at the data link layer of the OSI model and are responsible for forwarding data between devices on the same network segments. Between the same network segments, it will be going to forward the data. Layer 3 switches, these switches operate at the network layer. So layer 2 will be operating at data link layer. Layer 3 will be operating at the network layer of the OSI model and can route the data between different networks and route, and it was like forward. So at data link layer, the data forwarding is done. At network layer, data routing is done. They are more advanced than the layer 2 switches and are often used in large and more complex networks. Next one is PoE switches. So these switches have power over Ethernet capabilities. So they are like power efficient switches, which allows them to supply power to network devices over the same cable that carries data. So they will be having the data along with the data send. They are having the power capability. They basically provide the power supply to the different network devices connected with this POS switch. So gigabit switch, these switch support gigabit Ethernet speed, which are faster than the traditional Ethernet speed. Rack mounted switch, these switch are designed to be mounted in a server rack. So these are the rack mounted switches and are suitable for use in data centers and or over large network. So rack mounted switches, these are available in our university also. So desktop switches, so these switches are designed to be used for used on a desktop. Modular switches, these switches have modular design which allows for easy expansion of or customization. Easy expansion and customization, they are suitable for large networks and data centers. So based on different applicabilities, so different types of switches are available. So next we will see is the routers. So what the routers are there, we will be looking at that. So a router is a device like a switch itself that routes data packets based on their IP addresses. So its capabilities are like it will be doing the routing of the data. So the data at the network layer are basically called packets. So it will be routing the packets because it works at the network layer basically. So a router is a 3-layer device. So 3-layer, so physical, data link, and network that routes packet based on their logical addresses. So what is the logical addresses? So IP addresses or the logical addresses. Okay. So this is basically host to host addressing. So this host to host addressing is called the logical addressing basically here. So in between whatever the intermediate devices are there, they will be having their IP addresses. One is like end-to-end addressing, one, and this is like host to host addressing. So a router normally connects LANs and WANs in an internet and has a routing table. So similar to the bridge table, the routers are having the routing table that is used for making decisions about the route. What is the route? The decision will be made by using the routing table. Routing tables are normally dynamic and are updated using routing protocols. So different routing protocols are there that will be basically deciding like what different routing tables should be there for a particular path. So a 3-layer. So next is like, this is the 3-layer switch. So 3-layer switch is a router. So this is like routers, like a basic router is there. If it is a 3-layer switch, it will be like similar to the router. It is a router itself, but it will be having some higher capabilities than the basic router. So, but it is having a faster capabilities and more sophisticated. Means it will be supporting many applications or many functionalities. The switching fabric in a 3-layer switch allows faster table lookup and forwarding. So these are the capabilities that are making this 3-layer switch. That is nothing but a router itself, but it is you can say higher version or um, advanced version of the routers. So here it is going to say like how the router basically connect LANs and WANs. So this is the symbol of a router. So these are the routers. So these routers will be connecting a single LAN. So inside that LAN, there will be different topologies. Through that, different devices have connected inside that. And through this router, another WAN or LAN will be connected. So this is the different LANs connected with the router. This is the basic idea, like how the LANs will be connecting different, uh, connected by different routers basically. So yeah, the next one is the gateways. So gateways, as we have seen at the starting, like there is a 5-layer device, connecting device. So here a gateway, as the name suggests, is a passage to connect two networks that may work upon different networking models or the networking protocol. So if even if the different networking protocol or models are there, they can be connected by using the gateway. Gateway are the connecting devices. So it is, at the name suggests, it is like a gateway or the passage for transferring the data between two different networks also, So they work as a messenger agent, work as the messenger agents that take data from one system, then interprets it, and then transfer it to another system. So whatever the data is there, it will be interpreting it and then transferring it, taking the data, interpreting and transferring. This is the basic idea of the gateways. Gateways are also called protocol converters. So these are called the protocol converters because it can connect two different networking models. So its meaning is different networking model means both are having different protocols. They both are having different protocols, and communication can be, or the data transmission can be provided by gateways. That means it is able to convert the data format from one protocol to another protocol. So that is the protocol converter, and can operate at any network layer. So it can operate at any network layer. Gateways are generally more complex than switches and routers. So it is more complex, as it is having more functionalities. Definitely it will be having higher complexities than switches and routers. A gateway is normally a computer that operates in all 5 layers. It will be operating at all 5 layers of the internet or 7OSI models. A gateway takes an application message, then reads it, interprets it. This means that it can be used as a connecting device between two internetworks that use different models. Yeah, that we have already seen. For example, a network designed to use OSI model can be connected with another network using internet model or TCP/IP model. So two different model devices can be connected with the help of gateways. The gateway connecting, here we can write like TCP/IP model. So gateways connecting the two systems can take a frame as it arrives from the first system, then move it up to OSI application layer and remove the message. This is what it does. So whatever the data is coming from the other model, it will be moving to the up to application layer, and from the application layer, the data will be taken. The message will be removed from there. The gateway can provide security and used to filter unwanted application layer messages. So it can provide the security also, providing the security in the sense whatever the unwanted application layer messages are there, because it is going to uh, send the message up to application layer, and application layer message are recovered or removed from the packet basically. So that if the message is unwanted, it will be removing or filtering that message. So it provides the security also, the gateways. So this is the overall structure of different connecting devices. So we have seen the bridge and hub. So this is like different hubs are there. Bridges. So it will be like connecting different devices. It can be used for extension, but hubs cannot be used for in like the passive hubs are there. It cannot be used for extension, and some higher version of bridges are like hubs, active hubs basically. Active hub. Then there comes the switches. Then there are the routers. These routers are connected with like gateways. Okay, so routers will be like having a gateway, and it will be connected with like one ISP. Likewise, you can consider. So this is the basic idea about the different devices.